This is a typical problem. You have to find the nearest exit from given M/n maze. I mean, you have M/n maze, so your initial position is given as entrance. This will be your entrance. So from entrance, you have to find the nearest exit. Where plus represents wall, dot represents empty space. Here you have a test case. Here plus represents walls. There are two walls here. One is a empty space, and all these are empty spaces. So in this problem, you are situated at 1, 2. 1, 2 means you will be here. So from here, your nearest exit will be the top one. You have to walk 2 steps for the left one. And how would you find how many steps you have to take to get out of the maze? So that is a problem. I will explain it in a picture. So you have a maze. It has 1, 2, 4. It's a 3x4 maze. This is a wall. 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 You are initially placed here. You want to find the nearest exit. This will be your nearest exit. This takes longer path of 2 steps. This takes only 1 step. So that is the problem. So how will you proceed? To proceed with this problem, you can have a breadth-first search approach. You will be starting from entrance. Breadth-first search has standard format where you will be using a queue. Here you need a vector queue because you will be representing your position as an element inside the queue. So we'll have a queue, and while queue is empty, that means your exploration has not yet over. You will be picking queue size, queue dot size. While size is not over, you will be doing the breadth exploration inside the inner one. So how would you do that? You will be picking the top level, picking the current x and y. Index will be like, I will make it a pair so that it will be a bit more easy. We just need a coordinate system. I'll make it dot first, second. So you have both x, your current coordinate. And what was your objective? You need to find the exit. How do you go with this? Yeah, you can travel in 4 directions from x and y. Yes. You travel in 4 directions. That. Okay. Plus your next cell will be x plus layer of I, comma y plus t layer of I plus. If somehow or maze plus you want to continue the operation, you will not be taking. If somehow you hit a wall or you are out of the maze, then you won't be doing anything in that direction. Otherwise, if p equal to 0 or q equal to 0 or p equal to or q equal to, then the marking that is the answer, we will be returning it. So answer is like you are doing a breadth-first search. So when you do your first search of a breadth, you will be covering all these 4 columns. In your next breadth, you will be having one. You will be having this one, this one, this one. When you are here, we have all this 4. When you are here, you will be having this 4. When you are here, you will be having. In the second breath, you will reach either this exit or this exit or this exit or this cell. But these things won't happen because here is a plus and this is open. This will happen. This exit will happen. This won't happen. That's how the breadth for search works. You have go over a breadth. Your nearest, you will be searching over all the nearest in the queue. It has reached its stack size. Let's continue with solution. So that breadth will be, you have to define breadth first. Now you are searching on your first breadth. Once your search has completed in that breadth, you have to increment the size of the breadth. That will be your answer. If your answer is never hit over here, this M and N is the maze size. M and N are maze sizes. Is this over? Yeah. If it is not hit, then you have to mark that point PQ as plus. And you have to enqueue this for exploration. Q dot push P comma Q. So we have has this Q. Okay. We cannot use Q as is to change some variable. What is other? Okay. Okay. Not sure what. Let's compile and see. Yeah, it works in one step. It comes out. It is taking this path. So one step it will be reaching at exit. Hope you enjoyed this video. Thanks for listening.